Okay, Sharmin, you can go ahead.
Okay, thank you so much. So here, today we are going to see another tutorial based on RNN. So we will basically classify down some text. So mainly what the text are, they are movie reviews, IMDb movie reviews. So we will take the movie reviews, then process it, then put it in a model, and then we find a decision. So the decision can be it is a positive review or it can be a negative review. So this is the outline of our this tutorial. So the first one we'll see the setup, then we'll see the input and pre-processing. Next, this is how we create the text encoder. This is the similar as we show earlier what Yeah actually shown us. This is then we will create the model, train the model, then we'll get the results, and then we will just play with different models and find how the variations of the models are on the prediction results. So first, we'll see the setup. So you already, I think, get what installation of what packages we need for this tutorial. So basically, all packages are same as earlier. Just we need the TensorFlow datasets for this one. So this TensorFlow dataset, it already contains um, some predefined data already loaded in the TensorFlow datasets, like some popular models like MNIST, then the Cypher10. So and now today we will see that we will load the IMDb reviews. So let's see. Here we import this TensorFlow dataset. So we get this, we will take this help and we'll load this IMDb review. So with info here is just, we will get some information from this about this IMDb reviews. And as supervised means that we will take tuple data, like data and also the level. So if we just go ahead from the first one, so we'll just loaded this one, then we are going to load this one as well. So I have already have this data set into this CoLab, so I didn't have to download it again. But if you are the first time to do that, you see that there will be some other messages for downloading, and then you will see at the end this message. So if we see what is the info is, so if I just write info, it will basically give the overall description about what the dataset is about. So this is the home page. You can go there and download it manually from here from this website, and it contains about 25,000 test cases, test reviews, and train reviews. So we are not going to see the unsupervised 50,000 this one, as we are mainly focused on the supervised learning today in today's class. So and this is the reference of which paper you have to cite if you use this data set in your paper. So mainly this info contains about the overall information about this movie reviews data set, and then we mainly take the train part in the train dataset and the test part in the test dataset. And if we check what is inside this train dataset element spec, we see that there is a string and there is an integer tuple inside of this train dataset. So if we further explore what this two tuple is, so this is the train dataset. We'll take the first one. Here we will print the here we'll print the first review and the level. So we can see this review already says that's absolutely horrible movie. So we can guess that this is a negative review. And you can check further. If I give 5 here, so it gives us 5 reviews, the first 5 reviews. So you can see the fourth one and the fifth one, these are the positive reviews. So if you see there's snowy Sunday afternoon, then a couple of hour wonderful performance. So we can see this is a kind of positive review example. So in this way, this train data set, it contains 25,000 data, what actually mentioned here. So are we clear up to this part?
I have just one
Does anyone
question.
have any questions?
Yeah, go ahead.
So this take function here, so what does it do exactly? It retrieves them based on the review, whether it's 5, 4, 3, 2, 1.
No, this is just printing the reviews. Like 5 means you're just printing 5 reviews.
Oh, okay.
Yes,
Okay.
if you just give like 10, it will give you the first 10 reviews.
Okay.
And their corresponding levels.
And the label here constitutes what? Whether it's 0 or 1.
0 means this is a negative review, like terrible movie. So this is a negative review. And 1 means like this is a positive review. Like if you see this wonderful performance.
Yes.
So in this way, you can understand that whether this is a positive or negative review. So as we are doing the supervised learning here, so the text and the levels both are available for us.
Okay, makes sense. Thank you.
Thank you. So is there any more questions? No? Okay. Now so we are going further. So here, after we get the data, now we are going to do some processing. So here we are saying that we are defining some buffer size and batch size. So what the buffer size and batch size do? It will mainly the train data set. It will it's actually called the shuffle function, batch function, and then prefetch function. So this is actually a kind of like modification. Now the shuffle ones do is that it will just shuffle the data, then it will put it in the batch. Like there will be now 64 batches. So 64, 64, 64, 64 movies in this kind. It will create the batch, and prefetch is mainly like if when you are doing some processing here, prefetch already put some data in line so that everything goes smoothly. And we do the same for test. Just we don't need to shuffle in the test data set. Now here. If we see the same code, this was we see that we are taking the first 10 examples or the first maybe just first 1 example. We already saw this code. So now if we use this buffer and then the pre-processing on the train data set and test data set. So here now if we just take the first one, what are we seeing? This is the same code as the previous one. This code and this code. This has the same code as the previous ones, but it gives the first review and the label. But after some pre-processing, now when we take the first one, it gives us some long reviews. So what? So if we see, if we print this level, like length of this level, now we see there is now 64 labels and there is 64 reviews. So as we already did in the previous cell that we create in a batch of 64 size. So now in the data set, there is 64, 64, 64 batches. Okay. So now, after we creating the batch, now we go to see the text encoder. This is similar what we see in our last class. So here we will create a vocabulary size, and we'll call the text vectorization function and create the vocabulary size of 100 size dictionary. And when we call the adder function, it will just take all the text, only the text, not the label, only the text from the train data set, and it will create the dictionary. So if we run this one, okay, it will take some time. Okay, here it is. So if you it already created the dictionary. Now here, if we see what the dictionary is, it's only printing the first 20 words. So the first, except these first two, we can see that after there is no like alphabetical order. So how these are actually, how we actually got this words. So this is actually based on the frequency. So this this comes like the most frequent times. Then second frequent word comes is and. Okay, and if we see that the whole vocabulary list, so here is the whole 1000 vocabulary list, all of them. So you can check if you want to like see what all the vocabularies are. And you can also check whether there is like only the how many sorry, where is that? 1 second, here it is. So length of the vocabulary is 1000, so what we defined earlier. So after we created the vocabulary, we can also have some checking, like we can have some sentence and we can find what this encoded example is after we gave it into the vocabulary, the encoder vocabulary, encoded dictionary. So here you can see that these correspond to 11, E's correspond to 7, A correspond to 4, nice correspond to this one, 317, and pen correspond to 1. And you can also see whether this number is accurate or not. Like if you give here like 371, 317, then it comes that the index is nice. So nice comes as it is. So, but one interesting thing is that if you want to find the pen, like 1, it gives a thing that we don't know, this word. So when the encoder actually finds a word that is not inside of the dictionary, then it gives this unknown word level. So we cannot like imagine that all the words will be inside this 1000. So that's why this UNK level comes from. Okay. Here, the first one is the index one is always the unknown word, and the first one is always like this, means the spacing, that there is nothing, if there is nothing afterwards. So that will be pointed by index 0. So these two are special ones, and after that, these are just the regular ones. Okay, so after we find all this, now we came to create the model. So is there any questions before we move on to the model? No? Okay. So first here we came to the how we create the model. So there is already some layers are already defined in the TensorFlow library. Like the first one, this is the encoder. Then after the encoder, we find that it gives the embedding layer. Then it's using the bidirectional LSTM layer. Then it's the dense layer. And this is the afterward, there is another dense layer. So it has some kind of this type of representation. So first one is the input one. That was a great movie. This kind of reviews. Then there is, this is the input. So the input is not there. Then there is the encoder part. Encoder do this text vectorization, like just indexing of every word correspond to other number. Then this embedding layer. The embedding layer just create this number to a vectorized representation of a specific length. For every number, for every word, there is a sequence of vector. Then there is a bidirectional LSTM. This is one kind of like bidirectional LSTM. So what the bidirectional LSTM is? So the bidirectional LSTM is that mainly if you just think of only LSTM there, if you just think only LSTM there, then there will be just one layer of this. One, 2, 3, 4, 5. These 5 layers of this. But for the bidirectional, there comes another set of the same number of neurons. So the first neurons, they actually process this word from the forward, like this one, this one, this one, this one, this one, like that was a great movie. So it sequenced from forward to backward. The other set of layers, the purpose of having this is that it can check the sequence from backward to forward, like this, this. So movie great, A was that. So this is mainly having, this is mainly the reason of having layer of two bidirectional, having two directional layers of LSTMs. One is going forward and one is getting backward. And there is another dense layer. Dense layer is just the fully connected layer, and there is another dense layer, fully connected layer. So this is given the dimension sizes. So embedding layer will output 64 dimension. Then bidirectional, this also output the 64 dimension. Dense layer 64 dimensions, and the last dense layer is just one neuron will be there just. So okay, so is that clear? Or
I have a question. Why do you need bidirectional LSTM? Like, it doesn't make sense if I go backwards through a sentence.
Okay, this is a good question. I also was curious about this, but I found that bidirectional is mainly created if you are dealing with mainly for the like speech recognition or something like that. So you have to like understand what words you're saying, then what words you're saying later. So having a forward pass and having a backward pass, these two will give like the overall like scenario of what this speech really is. So that was basically the reason. So they found that having the LSTM and having the bidirectional LSTM, the bidirectional ones actually giving the better response, like better performance.
Okay, got it. Thank you.
Okay. So these are okay. So after having this model, after defining these models, we take these models and we can now predict from these models, but this prediction actually will not give any sense because we haven't trained this model yet. So this gives some warnings, but eventually, okay, this is the numbers, but this number does not make any sense here because the weights are just initialized and we haven't trained the models. So before we take any prediction, we have to train this model first, then take the predictions. But this actually gives you the notions that the model you have defined, this is correct, like how they are passing, these are correct ones. So here you can find that you can actually play with these models as well. So I made this in this way, like if we have just encoder ones, not the others. The other, there are 1, 2, 3, 4. There are 4 layers after encoder. So if you have only the encoder and you run here and you see that this movie was cool and you pass it through this model too, it will just give you the encoded numbers, just the dictionary numbers. 2 was correspond to D was correspond to 2, movie was correspond to 18, was corresponding to 14, and so on. Now this was the output. So if you just add another one, and put the dimension size smaller so that we can understand properly, like maybe 5. So you can see that this movie was cool. This simple text is now passes through this model, and we can see that there is now a vector of size. There is 4 words. The movie was cool, and there is now each word. This is now a 5 vector size. So how this 5 comes from? This 5 comes from here. So this is the output dimension. When you find this D word, it will convert it to a 5-dimension vector. Then the movie was converted to this vector. Then cool was the last vector. And you can also like increase the length as well. So you can see that 165. So for every 6 word, there is 5 vectors. Okay. So also you can then add the second one and the next one, so that you can understand that how the dimensions are actually getting they are actually getting different from each other. And if you have any like some kind of errors, then that maybe and they tell you that this you have an error here, because maybe that this LSTM, it wants the 3-dimensional tensor. So batch, it wants the batch, the sequence, and there's like sequence of for this one there is a sequence of words. So this is the 3 tensors. So if you don't get that, it will give an error. So you can just see up to this point that what is actually this up to this point, what is the tensor size. So if you see this tensor size is 3-dimensional, then you find that okay, this one is okay to get into this LSTM. So you can play with this one, play like this one, so that you can understand where the errors come from.
Hey, Sharmin,
Okay,
so
yeah.
for the last dense layer, we output 1. Is it because the label just can be represented by 1 digit?
Label can be represented by 1 digit, and also by 1 you can have just 1 output. So only 1 output number. So this 1 output number, if we find that this number is positive, then this is the number is positive, then this is a positive review, and if the number is negative, then it's a negative review. So that's why we are getting just 1 numbers from these models. not multiple
And
numbers.
then you know things like French to English translation, then this output will be longer, you know, like a
Yeah,
sentence.
the output will be longer. And also, if you have like if you have not binary classification, if you have like multiple classification, like maybe 10 levels there, now there is only true and false. But if the levels are maybe true, false, neutral, something like this, like 3 class. So in that case, you can also give 3 here. So you will get 3 class, and if you just do the softmax at the end of the layer, then activation as softmax, then we'll get the probabilities.
Right, yeah.
Getting the probabilities, you can understand that which has the highest probability, the corresponding index will be the answer.
Yeah, gotcha.
Okay, in this case, we could have also used 2 at the last layer, right?
Yeah, we can also use 2, but in that case, if you use 2, you have to use the activation equals to softmax.
Like softmax function.
Yes.
Okay, got it.
But they didn't use softmax, they just get 1 numbers and just do it. Okay. All right, so we have these models. I will just run it again. So now, if we compile these models, we'll get just the accuracy. We are using the optimizer, Adam optimizer. Then we are getting the losses binary cross entropy. And then this is another thing. In the tutorial, you'll find that they use test data set as validation data. But in general, it is said that you cannot use test data set into the model training part. So that's why I just take the validation data set from the training data set, 100 batches I take as the validation data set, and then the others, these are taken as train data set. So this is the validation and this is the train data set. Now if we fit this one, is there any questions after this fitting part, training part? So it will now train the model. Somehow it is a little bit slower. So you can see that there is only accuracy value, which is given here, but you can also include others, like if you want to see accuracy, also precision recall values. In addition to this accuracy value, you can only have to put it here when you compile the model. So matrices, here is only the accuracy one. So if you just put precision recall in here, then you will also see that it will also show in here.
Okay, I have a question. There are different types of embedding. So which embedding we are using in this case? Like what to fake or something like that?
We are using word to fake.
Okay.
Will word2vec be used after the model is trained?
No. We are using it in this in here in the model.
Oh, okay.
So if you see that they also give some descriptions here, like encoder is after encoder embedding there. So as I have told that it creates a vector size of 64 dimension for each word.
Okay, so this is an internal implementation of Word2Vec in Keras, right? Okay, all right, okay, makes sense.
And so would this be so would the embedding trained along with the review, like along with the task? So like
Yes.
sort of like together.
Yeah. This this part is getting trained together, except the encoder part.
Right. So could one also train them separately? Like you train the word embeddings first, and then use that embedding to do the task, and then you could also use the embedding to do other tasks. Would that also work?
It can work. There is a concept called transfer learning. I think that can be you can separately train there, but
may not be very good because this
yeah,
is
but
very
yes, but may
tailored
not
for
be.
this
Yeah,
task.
yes. If you train them together, it will give you a better performance than train them separately.
Yeah.
Okay, so in any case, if we swap the labels of this data set and train it again with the same set of like random variable, will we get the same embedding vectors from the word, or it will change based on the context of the output?
Um, embedding vectors. I think they will. Maybe they will get changed as you flipping the numbers like 0 to 1, 1 to 0.
Okay.
The levels are like flipped, so definitely the embedding will value will be changed there.
Okay.
Okay, so here is the 10 epoch. So if you see the test accuracy, you find that okay, there is. Okay, so this is the training, the test accuracy, and if you see that this is now a simple review example, and if you predict it using this model, then you'll find that this model shows 95. So 95, and if you just change it, like this movie was horrible, the graphics were not out of this world, and I would not recommend this movie, then find that there is this minus prediction. So negative result means negative prediction, and the positive ones is the positive predictions. And if you see that here the matplotlib, if you plot this accuracy versus the training accuracy versus the validation accuracy, you see that it's actually continuously increasing. It's also continuously decreasing. And if you increase the number of epoch, then I think you will get like a better accuracy, as it's actually continuously going upward or continuously going downward. So you will get the better accuracy. The thing is that up to this point, the thing is that maybe you have one data set and you find that you put some like these layers, and also you define the optimizer, the learning rate, and you are maybe not certain like which one is like the proper one for you. So you have to do some parameter tuning. So the parameter tuning is that maybe you have to like it. For example, here it then stack 2 or more LSTM layers. So here, if you we have one LSTM layer before, now there is another LSTM layers, and you can see that here it says that return sequence true. So the why we define here the return sequence true, because we haven't do that in our previous ones. We haven't defined the return sequence true here. I have already said that LSTM, it needs the 3D tensor, the batch size, the timestamp, and the output features. So that's why when you are again training this with LSTM layers, like stacking 2 LSTM layers, one after another, this one also need to take return, need to take the sequence output. So that's why we are returning all the sequence from LSTM and passes it here. So the rest of them are similar, and if you train it, then you find I already trained this model to save time. So you find that the training accuracy is now, the test accuracy is now 0.86. The previous one was 0.85. So it is actually just a very little improvement, but you also can tune other ways as well, like this number of neurons. You can change the number of neurons as well. You can change the activation layers. You can change the dropout values. Then this learning rate. Learning rate sometimes changing the learning rate, it gives you like better performance if you like lower the learning rate, like giving an optimum learning rate, not much lower but not much higher. So this is the result for stacking 2 LSTM layers. These 2 LSTM layer stacking, the result is like this one. And also then you can here I use the activation sigmoid here so that you can understand. So if you check this sigmoid value, so it's also the same layer because I just only added the sigmoid one. And if you see that this movie was horrible, like not good, graphics are horrible, and it gives not it doesn't give a negative result. So this actually shows the probability ones, a probability result, because we use sigmoid here. As we use sigmoid, you will not get any negative value. So it gives up like a probability value. So seeing this value is that it's very lower, like close to 0. So you will understand that this will be a negative review. And if you find that the probability is like very higher, like up to above 0.5, so you will understand that that would be a positive review. And also, if you want to use the simple RNN, I thought about giving this like I wanted to train this model using the RNN here. I just use the simple RNN here rather than having the LSTM. But it's actually like taking a lot of time. So after that, I didn't wanted to run this one. And you can also use just the simple LSTM, not the bidirectional one. So just a simple LSTM, then you can run the model and you can also check the accuracy. Okay, I didn't get the test accuracy here. I think I can get it now. Okay, so the test accuracy is also like similar to the other ones. So 0.85. So these are just some types of layers you can add and use and change the values, change the parameters, and also the neuron size, and see which one actually gives better performance for the dataset you want to use these models. Is there any questions?
I have one question regarding the, like, if you go a little bit up when you get to the predictions, you don't do any comparison here, right? Like here you're just printing out the number only, but like as an extension to this, there would be like a cutoff value where this is a positive review and a cutoff value where this is a negative review. Is that correct? Not just plus or minus.
Uh, you are asking about this one?
Yes. So the prediction here is 0.15, even though the review itself is a should be negative, should be 0.
Oh, no, no. That actually was what I was telling you about, because this one we are getting the probability output from logit. So we use the activation sigmoid here. We didn't use the activation sigmoid before.
Oh,
So
okay.
sigmoid actually gives you like this type of shape,
Yes,
like
yes.
this star from 0, star from ends at 1. Like it gives you a probability value, the sigmoid one.
Hmm.
So when you use this sigmoid value, then you will get a probability value. The
Oh, okay,
probability
okay.
value will not be minus.
Yeah, this was without the sigmoid. This number right here is without. So we'll have to do the retraining and everything to get the sigmoid value with it over there.
Yeah, if
Yeah,
you
okay.
want to use the if you want to get your output as a probability value, like above 0.5 it will be positive, lower 0.5 it's negative. If you want to get some kind of like this kind of probability value, then you will use the sigmoid.
Yes, okay. Sigmoid added, not instead of something. So sigmoid is an addition to the model itself that was there,
Yes,
or is it instead of something?
and this is as an activation function.
Yes, okay, okay.
You can use this as an activation function. You see, we haven't used sigmoid here.
Yes, okay, all right. Thank you.
Any other questions?
I have a question with word embedding. Like, if I have any like punctuation mark after the word, like concatenated with the word, then it will treat that word different from the word that doesn't have any punctuation mark. So how can I
Uh,
remove this problem, or is it a
regarding
problem?
the punctuation one, I think sorry, I haven't mentioned about this one. When you see this example, remember,
Yeah.
so you have this 11, 7, 4, 1, then nothing. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There is no punctuation. There is no value for this punctuation.
I think
So
punctuation mark is added to that word pen. Like it is
no,
okay.
no.
Okay.
Is not added to the pen. Like if you hear nice movie, it's giving 18. So if you see what 18 is, this is only the movie,
Okay.
not the punctuation one. So here is the trick: is that when you use the text vectorization, and you can see that lower, when I put this here, there is the standardized equals to lower and stripe punctuation. There is something written here, you see? So
Okay.
it takes this standardized form. So it
Oh,
will lower all these values, like lowercase all these words, and also strip the punctuations. Like here, this is
okay. Got it.
this value, this is the capital one. But if you see that what is inside of the 11, then this is only the lower case this, not the uppercase this with capital T. So it will lowercase, and also it will strip the punctuations as well.
Okay. Thank you. I understand now.
But you can also change this as your own. Like you can also modify the standardization form if you don't want to like skip these punctuations.
Okay.
So any other questions?
Is it is it possible to find um a wrongfully classified review, and then we can take a look to see why it is wrong. Is it easy to find such a review that is classified wrong?
Classified as wrong, I found when I was trying to do this part, I found that when you use like when you negate some words, like there is a nice, and this is a nice movie, maybe when you say that this is not a nice movie, like negate one or two parts, the probability values, it gets lower.
So
But
if you say not so bad or something like more complicated that could cause confusion.
yeah, it can cause confusion, and also it just maybe lower the value, like if
Right,
it
yeah.
gives you like 80% confidence that this is a this is a positive review, then the confidence level goes lower, like 70%
Yeah.
confidence and this is a nice movie. But if you use
Right.
like definite words like horrible movie, then the prediction level goes below 50%. So
Right.
then you
So
can,
if something like more ambiguous, you say this is worse than the best movie that I've seen, but then it's better than a lot of movies, and then so that's caused some confusion that could be classified harder. Yeah.
yes. Yes, and I think I forgot to tell everyone to take a snapshot.
So could you maybe quickly go back and then just if you could like remind them the place where
Um,
they should take.
uh, okay, for report, I think they can take a snapshot here, the first step that our um,
Yeah.
dictionary was created.
And the others.
Okay, then after that, one thing is here, like how they can play these things, like how these output dimensions, like how these embedding actually works. Okay.
You can continue
Then
because a lot of them are gonna watch the video, the recording, and then do the
okay.
assignments. Yes.
All right. Okay. Then there is another part. So the training accuracy and testing accuracy for the bidirectional Lstm part. Um, and okay, this is the training accuracy from the other ones, the prediction ones, the probability ones. So they can also take a snapshot here. And a simple RNN, I didn't do that. They can also just like the ordinary LSTM ones. So they can just put this in the report as well.
All right. If we don't have any more questions, then I think maybe we can end early, and you guys can start working on it. I will make sure the video gets uploaded and notify you as soon as possible. All good. See, all good. Okay, I'm really glad I learned a lot. And thank you so much, Sharmin, for showing this. And I hope that this is also, just give you some more confidence that this is not, neural network is not that difficult. And then you can, like there's a lot of tools and for you to work with. And hopefully when choosing your projects down the road, that you have something to work with. And so don't be afraid to break things and just to try, like Sharmin showed, change the numbers, play with numbers.
And the main thing is that you have to know which method you have to call. That is the main thing. And so this is not like any programming task. So in the programming, you have to know the logic and how you will um, provide a good answer. But in very efficient way. But here you have to know a lot of library, and there is also like a lot of library are coming out, and they're like putting your task very simpler. So you have to just know which library you
So
want.
where
and,
would you find the libraries? So what's
uh,
the way
mainly if you want to know, like if you know that which task you have to do, then you can see the PyTorch tutorials or TensorFlow tutorials, and I'm sure that they give actually a lot of examples there, and you can just know that you will find that, like if you find that one task is like similar to what you want to do for a different data set, then you can just go there and you can like
code
look,
snippet?
like look at their technique, like how they did that, like which layers they have used, and and you have to just do the parameter tuning to feed the model based on your data set.
Yeah, great suggestion. All right then. So I think we can just stop here, and I'll stop